Hello everyone, this is Jason. In this video, we'll talk about the parameter settings in ZW3D 2x CAM, in which I will introduce the overview of parameter settings and 2x common parameters. Primary parameters, limiting parameters, tolerance and steps, path setting, link and lead, and display parameters. First of all, I will introduce the overview of parameter settings and 2x common parameters. The common parameters are divided into 6 tabs. Through reasonable parameter setting, user can get the required 2 paths. Here, please note that the following parameters are used for a better demonstration, not for actual processing. In the upcoming slides, I will introduce the tabs one by one. So the first one is primary, is to set custom coordinate system, features, tour, spindle speed and feet used to calculate the 2 paths. The second one is limiting, is used to define the boundary of the 2 paths, including the top and bottom, and whether to consider all faces of the part when generating the 2 paths. Now let's switch to ZW3D and check these 2 tabs. These are the common parameters listed in the dialog box. So we go to the first tab in the dialog box. Frame is to set the custom coordinate system to calculate the 2 paths. None means using the default system, which is the world coordinate system. There are 2 ways to create custom frame. You can click Manager to open the frame dialog box. The datums created in CAD environment will be displayed automatically in this step. Then select the datum and change a color if you need. Then we can generate the 2 paths based on the custom frame. The other way is to right-click on Frame tab, then create a datum directly in CAM environment. Then the rest steps are the same as the first method. Then is the Features tab, is to add, remove, or edit the features. The last one of the primary tab is Tour and Speed Feed. Click Tour, you can select the tour from the list. An Edit button will open the Tour dialog box. Click Speed Feeds button will open the speed and feed table of the operation. You can specify different values for a specific part of the 2 paths. For example, the traversal change to rapid. And you can also set the speed and feed value and units. Please note that the initial speed and feed value and units will be inherited from the tool. For example, I select another tool. The value and units will be inherited from the tool. The next tab is limiting parameters. There are 3 types to define the processing depth in Z direction. Absolute is using the absolute value to limit the 2 paths in Z direction. You need to specify the top and bottom point. Relative to top and bottom are related to the position of the profile. In this case, the profile is on top. The depth relative to top is 6 mm. You can see the 2 path effect. And next one is check option, is to define whether to check the surface of all parts involved in this process to avoid overcutting 2 paths. Now let's take a look at the differences. This is the profile used in both operations. If the option is off, ZW3D will generate the complete 2 paths within the profile. If the option is on, ZW3D will check the surface of all parts involved in this process to avoid overcutting two paths. Now let's go ahead. Is tolerance and steps. It contains tolerance and thick and steps parameters. The two-path tolerance is the tolerance between actual two-path and ideal two-path. And the side or bottom thick is to set the remaining materials on the side or bottom. And for step over value is to define the distance between adjacent two paths. It has three ways to specify its value. Okay, the next one is step down. The commonly used types are uniform depth, base only, and non-uniform depth. Later I will show you the details. Next is the fifth tab, path setting. It contains most options to optimize the two paths. The first one is cutting control, about the cut direction, climb, and conventional, also called down and up cut. The difference between these two techniques is the relationship of the rotation of the cutter to the direction of feed. In conventional milling, the cutter rotates against the direction of the feed. During climb milling, the cutter rotates with the feed. The next one is the cut order. It's useful when there are multiple processing regions. Then is path pattern. The different patterns are listed below. Now let's go to ZW3D to check these options. First one is path tolerance. The default value is 0.01. The smaller this value is, the closer the actual two path is to the ideal two path. But the calculation will also increase. And the next two are side and bottom thick. It means the remaining materials on the side or bottom. Now I put the tool on the two path and switch to the front view. You will see the effect. Then is step over value. If the type is absolute or the percentage of the tool diameter, ZW3D will specify the distance between the tool tips according to the value. If the type is scallop, ZW3D will specify the step over value according to the cusp height. Next, I will introduce the step down type. The first three are commonly used. If using uniform, ZW3D will generate two paths with uniform depths. And base only, as its name suggests, it will generate the two paths only on the bottom. And non-uniform, from top to bottom. After first meeting the first and last step value, the two path is generated by taking a value from the minimum step to step down value. Then we jump to the next step, path setting, cutting control. You can set the cut direction here to be climbed or conventional. And next one is cut order. We can check the effect through Verify. When it is region first, it will finish the first region, then jump to the next one. And if it is level first, it will finish the first level in each region, then go to the second level. Then I will introduce the path patterns. Take spiral cut operation as an example. This is stepped outward and step inward. And the spiral outward, and the last one is spiral inward. If you want to engage from outside, you need to set it as the step or spiral inward. Now we back to the PowerPoint and continue the introduction of path setting. Finish path is to define the side finish type, number, and distance. It has four types: none, cleanup current level, single cut cleanup, and multiple levels cleanup. Here we need to know the concept of cleanup toolpath and filling toolpath. Cleanup toolpaths are the last toolpaths close to the feature boundary of each level, and filling toolpaths are inside the cleanup toolpath. Later I will show you the details in ZW3D. Next one is corner control. It's used to define path pattern at corners, side finish radius, and slowdown distance. Here list 4 types of path patterns at corners: radius of cleanup toolpath, and the slowdown distance before the arc. This is the last part of path setting, point setting, is to define the start point, tool home start or end points, and preview points. Commonly used are start point and preview point. Now we back to ZW3D. See, these are the cleanup toolpaths, and these are the filling toolpaths. This is the effect of none type, means there is no cleanup toolpath, and the current level and multiple levels. You may find the toolpaths of current level and multiple levels are almost the same. They will generate cleanup toolpaths for each layer. But for the cleanup current level, after finishing each layer, the cleanup toolpaths will be performed first, then go to the next layer. While multiple layers cleanup option, after finishing each layer, the cleanup toolpaths will be performed from the top to bottom. We can use verify to check the differences. Now is cleanup current level. After finishing the filling toolpath on first layer, it will perform the cleanup toolpath of the current level first. Then is multiple layers cleanup. It will finish all the filling toolpaths, then perform the cleanup toolpath from top to bottom. The last one is single cleanup. It will only generate the cleanup toolpath on the bottom. Here you may find there are 2 cleanup toolpaths. This number is specified by the side finish number option, and you can also set the distance between these cleanup toolpaths. Next part is the corner control. This is the toolpath with different concave corner type: standard, round, and truss cut. And this radius is specified by side finish radius. Now it is 10. I will change it to 0. It will become a right angle. And the slowdown distance is the toolpath length before the arc. It's mainly to prevent the machine from shaking strongly when turning direction. Now I set to 10. The speed and feed value of the slowdown section are defined in primary, tool, and speed. The last one is D-loop. It's mainly to protect the convex corner. Then the last part of path setting is point control. Commonly used are start point and preview point. Now look at these 2 paths. The original engage is here. Then I add a start point to the other side. Then the engage point will change to the other side. And if I add a preview point, the tool will approach to the start point from the specified preview point. After the introduction of path setting, we back to the PowerPoint to see the next tab, link and lead. The following tables list the link height situation of inside region, between layer, and between regions. Besides, the plunge type, plunge height, and plunge angle for 2D pocket operations can also be specified here. and the lead-in and lead-out parameters are used to specify the lead-in and lead-out type and the relevant settings for 2D contour operations. Next is the last tab, Display. As its name suggests, is used to specify the display settings of the toolpath, such as style, width, or display mode. Now we switch back to ZW3D. First, I will introduce the link type inside region. The clearance C is specified here. This is the link toolpath inside the region. If there's no stock under the feature, ZW3D will consider the top face of the workpiece as the blank plane. So when you select blank plane for inside region type, the link position will be on the top face, but you will find it's a little bit up above the top face. That is because, except traverse strain and clearance D link type, safe height will be added to all other options, which is the value of 2.5 in this case. Now, if I change safe height to 5, the link toolpath will be higher. Then is previous plane and clearance Z. Then is the link option between layers, because the other three options are the same as the ones introduced previously, so I will focus on the traverse strain option. This is the end of the first layer, and this is the start of the second layer, so the tool will traverse straightly. And then are the options for between region. The safe height option actually is the same as blank plane, because with or without a stock under the Features tab, the safe height will be added to the top face automatically. Then we move to the plunge options. Plunge type is used to specify the engage type for 2D contour operations. First is the helical type. Plunge height is from this point to the face. Now it is 2.5. If I change to 5, you can see the difference. Plunge angle is the angle between the tangent of the arc at the engage point and the face. Now it is 20. We can change it to 30 to check the effect. Plunge radius is the percentage of the tool diameters. Now it is 80%, and I will change it to 100% to check the effect. Then is ramp type and straight type. And I will not repeat the plunge height and plunge angle of these two types here. Next, I will introduce the lead-in and lead-out type for 2D contour cap. First one is linear and linear. This is length 1, and the other one is length 2. Second one is circular and linear. This is length 1 and the arc radius value. And the third one is circular and linear and linear. This is length 1 and arc radius value. The fourth one is circular slope. The setting will only take effect when the engage and retract type are all circular slope. The corresponding parameters, please refer to the image in the PowerPoint. The last one is none. And if you finish the settings in engage or retract, you can copy them to retract or copy from retract. And retract overlap is to set overlap to path lengths when retracting. Then the next one is the Display tab. We can specify the style, width, and display mode of the toolpath. And we can also customize colors for specific toolpath elements and whether to show them. For example, I switch Engage toolpath to magenta and hide the Rapid toolpath. Okay, that's all for the parameter settings in ZW3D 2X CAM.